Good afternoon, everybody. So a quick announcement. There is a quiz. So your first quiz is, well, for Friday, it's just Friday. For the other two lab groups, it's next Tuesday and Thursday. So the quiz content only covers up to arrays and strings. So it goes up to arrays and strings, and that's it. You don't need to know how to use a list or anything like that. I will put up a sample quiz later this evening. Later this evening. So that you can see what to expect. So the quiz is, officially it's 90 minutes long, but it's actually really only an hour-long quiz. So you should have ample time to at least attempt all the questions on the quiz. It is written, unfortunately, but I mean that's just the way it goes. If you have your computer, there's no way I can restrict like what you do when you have a computer, right? You can go on the network, you can just Google the answers for all the questions. So unfortunately, it is a written quiz. All right, so it is during your lab. Yes, sorry.
Are there any multiple choice questions?
I normally don't ask multiple choice. Yeah. So normally I don't ask multiple choice. If there are multiple choice questions, they're not the ones you want to see. So they're not the easy kind of multiple choice. So normally I don't ask multiple choice. Any other questions? All right. Yes?
Regarding our lab,
Yeah.
is there no pre-lab for this week?
No, there's no pre-lab. You just need to know how to use arrays and strings a little bit. Yeah. Today's topic are maps. So a map is, so you probably haven't seen a map data structure in your previous programming courses. These things are also called associative arrays. So you can think of a map as being an array where instead of using an integer index, you use something else. Right? So you use some other piece of information as what's called the key. Right? So these go by, they go by the name associative array, map, or dictionary, depending on which language you're working in. Java calls them maps. Right? So they're all names for the same type of data type. So I'm just going to skip over the. I don't think you guys take Sys 235. You've already taken a data structures course. You may have seen. Have you seen an associative array? No. Okay. So this will be a little bit new. So this doesn't mean anything. I should really change these slides for you guys. So a map provides functionality to what's called a dictionary in Python. Right? So in Java. There's something called a map. You get to choose between which type of map you want to use. So there's something called hash map. There's something called tree map. Right? So hash map is the faster version of the map. Right? Tree map is the slower version of the map. Did we do the set lecture? We did the set lecture, right? Last lecture? Yeah. Okay. So hash map corresponds roughly to a hash set. Tree map corresponds roughly to a tree set. So the hash map is faster than a tree map. Tree map keeps its keys in sorted order. Right? So if you need a sorted map, then it's probably tree map that you want to use. There is a third kind of map that's also, so linked hash map is analogous to linked hash set. Right? So hash map doesn't guarantee the ordering of the entries in the map. Linked hash map does guarantee the ordering, and it's the ordering in which you put things into the map. All right, so the way the map works is that a map groups elements that are accessed using a key. Right? So just like with a list where you can access elements using an integer index, right? You can access an element in a map using a key. Right? So in a list, your indexes are unique. Right? So in other words, the index 0 always corresponds to the first element. Right? So in a map, your keys must be unique as well. Right? So this is a generalization of an array. Every key maps to at least one value, and multiple keys are allowed to map to the same value. Right? So your values are not unique, your keys are. Right? And so in a map, the key value pairs are called entries. This is all great, but it's much easier just to see, oh, sorry, I just need a picture. There's a picture of a map. Right? So a map is just a two-column table. Your first column, the elements are unique. Right? So your first column forms a set of elements. Your second column, these don't have to be unique. right? And the way you read this is you just look at each row, right? So the key January maps to the value 31, right? So in other words, January has 31 days, right? The key February maps to the number 28, maybe 29 if it's a leap year, right? The key March maps to the number 31, and so on and so on and so forth, right? So column 1, the keys. Column 2, the values. Each row is called an entry or a key value pair, right? It doesn't matter what you call it, right? Normally people call it an entry because it's shorter than key value pair. Okay, so these are examples of when you might use a map, right? So a mathematical function, you may also know, or your calculus professor may have also called that a mapping, right? So in a mathematical function, every value x, right, maps to some value y. Right? So your keys for a mathematical function would be the x's, right, and your values would just be the y. If you had a dictionary, so this would be like an English language dictionary, right? You would have your keys would be the words in the dictionary, right? And your values would be the list of definitions for each word. If you wanted to map the number of days per month, your keys would be the months, right? And your values would be the number of days, and so on and so on and so forth, right? So the values, they can be any value. So for example, if I were to keep your marks in a course, right, the key might be the student number, right, because your student numbers are unique, right? And my value might be another map, right? And inside that map, I might have the name of each assessment item, so that would be my key, right? And then your grade would be the grade for each assessment item, right? So the value would be the grade for each assessment item, right? So you can have a map of maps, for example. Okay, so to create a map, you need to pick a map implementation, right? And so normally you pick hash map because it's the fastest, right? So by fast, I mean it's very fast, right? Get, put, and contains key. Those are your 3 basic methods. Those are all O1 expected complexity, right? So constant time complexity. Very fast, but you can't, if you iterate over the keys of the map, you have no idea what order they're going to come out in. Furthermore, if you take something, put something into the map or take something out, the ordering of the keys can change. The other common choice is tree map. So that's when you want a sorted list of items, sorted set of keys, sorry, for example. Right? So for a tree map, the keys are sorted. Complexity is O log n for the fundamental method. So still very fast, but not as fast as hash map. For the example, this example here, you wouldn't want to use either tree map or hash map. Right? If you had a hash map, all your months would be in some scrambled order. Right? So the entries would be in scrambled order. If you had a tree map, they would be sorted, but they would be sorted by dictionary order, right? So lexicographical order. In this example, this is an example where you'd want to use a linked hash map, right? So in a linked hash map, it's very fast, so it's still O1, but the linked hash map keeps extra information. So it stores what order the keys were inserted in. Right? And so it'll keep your keys in insertion order, which you'd probably want for this example here. Right? If you wanted to iterate over the keys in this map, you'd want to do them in the order in which the months appear. Right? So here would be an example where you use a linked hash map. The problem with the linked hash map is it actually stores the keys twice. Right? Once for the insertion order and another one for the map itself. So it uses a lot of extra memory if your map is large. Okay, so there's some fundamental methods that you need to know in order to use a map. So one of them is put. So put is the method that adds an entry to the map. Right? So in other words, if I wanted to insert a row into this map, the method that I would use would be put. Right? So when you make a map, right, you have to remember that a map has a key and a value, right? So every entry is made up of a key and a value. They can have different types. So when you specify a map, you need to specify the type of the key and then the type of the value. Right? So for the map of provinces to capital cities, they're both strings in this case. So I have a map of string, string. Right? I'm going to use a tree map in this case, just for illustration purposes. Right? So the put method, takes a key and a value pair and puts them into the map. Right? So the first time, so if you call put Ontario Toronto on an empty map, right, then the key Ontario is put into the map and it's associated with the value Toronto. Right? Put returns a value. So let's just pull up, sorry? No, hang on, I need to, I need a web browser. Oh, this stupid thing, sorry. This is a pain in the butt. Sorry, oh, is it gonna let me get to the, no it's not. Sorry, give me a minute while I deal with my web browser. I have to, there we go. Is it gonna let me, there we go, that's better. Okay, Java 8. All right, so if you pull up the documentation for the map, and look for the put method, you'll find it right here. Okay, so put associates the specified value with the specified key in the map. Right? So if you click on the detailed documentation, right, it tells you it actually returns a value. Right? So it actually returns a value. Right? So the value that's returned, if the map previously contained a mapping for the key, the old value is returned. Right? So it's replaced by the new value and then returned by the method. Right? If the key is not in the map, then this returns, where is it? Null. Right? So if you put, so the first time you call put on a, if you call put on an empty map, right, then put is going to return null, indicating that there was no previous mapping of this key. Right? Now the keyword null, I don't think we've used it all in the course. Right? So null in Java means no object. Right? So any reference can be assigned the value null. Right? You cannot assign null to a primitive value. Right? So if you have an int x, you can't say int x equals null. Right? But if you have a reference variable, you can assign the value null, which means no object. If you try to use a null reference, then normally what happens, if you use a null reference to call a method, then it almost certainly causes an exception to be thrown. Right? Because to call a method, you normally need an object. Null means there's no object. So you end up with what's called a null pointer exception. So you have to be a little bit careful when you use the value null. Similarly, when you have a method that returns the value null, normally you have to check if the return value is null before you use it. Right? So put's one of those methods. Right? If you keep the return value for some reason, and normally it is often useful, you have to check that the return value is not null before you use it. Otherwise, you risk getting a null pointer exception. Right? So keep that in mind when you're using maps. All right. So this this code here. Yes. Question. No, so here I'm just calling put and throwing away the return value.
And also, I thought you mentioned it one time. Do you need to put string and string in the tree map?
Over here?
Yeah.
No, you don't. No, not in any version of Java past 7. Yeah. So this one just puts in the provinces and their capital cities, but the territories are missing. Yes?
So if you use the string, would that just be for yourself in the new part?
Yeah, actually, I don't know why it's here. Most Java programmers won't put this in anymore. So most people would write it that way. It gets very tedious having to put in the types all the time. Right. Oh, there's something funny down here, actually. Notice that when you put St. John's into as a value, you have to, if you try to put St. John's in with a single quote on its own, it won't work. So you'll get a compiler error. So remember, the single quote is used by Java to indicate a character. Right? So if you use a single quote anywhere, even inside of a string, right, the compiler will look at that and say it's expecting a character. Right? And so in order to use the single quote inside of a string, you have to, we say, escape the character, just like you would escape characters in C. Right? So you need a backslash single quote here if you want the single quote inside of a string. Okay, so after running that example there, you would end up with a map that looks like this. Right now it's a tree map. Right? So when you look at the map, the provinces are in sorted order, right? Alphabetically in this case, right? Each province maps to a different capital city. All right, so if you want to get a value from a map, then the method's called get. Right? How do you get a method from the map? Well, you pass in a key. Right? So this is like using a list with an index, except now, instead of using an index, you use a key value. Right? And so the way this works is when you call get, the map looks for a key that's equal to, in this case, Ontario. Right? So back in this map here, we have a key that's equal to Ontario. Right? And so it returns the value that's mapped to that key. Right? And so in this case, it returns Toronto. Right? If that key is not in the map, right? So in other words, if the map discovers that there is no key equal to Ontario, then get returns null. Right? So again, you have to be a little bit careful about using the return value from get, right? Because it can be null, and if you use it without checking if it's null, you risk with getting a null pointer exception. Yes?
So if you were to use get, should you always throw a command to check?
You don't throw the exception. Normally what you do is on the next line. So if you have reason to believe that that key is not in the map for some reason, then on the next line you write an if statement. Right? So if city equals null, right, then you know that you can't use city for anything. Okay, so to determine if a map contains a key, there's a contains key method. Right? So remember, in list, there's a contains method. Right? Same way with set. In Java, you ask if it contains a key. Right? There's also a contains value. So contains key returns true if the specified key is in the map, and it returns false otherwise. Right? So if we have the same map of capital cities, of provinces to capital cities, I can do something like the following. Right? I can ask the map, right? Does it contain the key Nunavut? Right? And if the answer is false, so if not, right, then I'm going to add the territory Nunavut with its capital city Iqaluit to the map. Right? And I can do the same thing with the other territories. Right? And so there's an example of using contains key. Right? So I'm going to check, does the map actually have this key in the map before trying to put it into the map. Right? If I don't check first, then it's going to overwrite whatever's in. If the key is in the map, it will overwrite the old key, right? Which you might not want to do, depending on the problem you're trying to solve. Okay, so what would you use a map for? So it turns out maps are really useful. So lists are obviously useful. Arrays are useful. Maps are probably as useful as lists. Because it's often the time when you want to when you have something that looks like a list, but you want to index it with something else, right? And that's when you want to use a map. So one of the useful things that you can use a map for is to count how many times does stuff appear in another collection. Right? So suppose we have a list of strings, and I want to know how many times each string occurs in the list. Right? Now you could do this with just a list. Right? So I can count how many times every element of the list appears inside the list. Right? How would you do that? You would write a loop. Right? So you'd loop over the elements in the list. Each time in the loop, you would loop over the list a second time. Right? So you're going to get an element from the list, and then I'm going to check every element in the list again to see if it's equal to that element, right? To count the number of times it appears. Right? And so now if you do that, you have an O(n) squared algorithm. Right? You have to process the list. You're processing the list inside of a nested loop. Right? If you use a map, you can do it a lot faster. Right? So the way you use a map to process this list of strings is your keys become the strings that are in the list, right? And your value becomes the number of times each string appears in the list. Right? So the way this works is you make a map. Right? Your keys will be the strings in the list, right? Your values will be the number of times each string appears in the list. So I'm going to call this map count. Right? Now you loop over your list. Right? So for each string s in the list t, right, you ask the map, do you contain the key s, right? Or do you contain the word s? Right? If the answer is yes, then you ask the map, how many times has s appeared? Right? Because the map is keeping count of how many times it's appeared. Right? Then you add 1 to it. Right? So you take the current count, add 1, so n plus 1, and put it back into the map. Right? So you overwrite the old count for the word s with the new count, n plus 1. Right? Here we don't care about getting the return value. All we want to do is overwrite the existing value. Now if s is not in the map, right, then this is the first time you've seen s. So go ahead and put s into the map, this time with a count of 1. Right? And that will count all of the words in the list, and it also gives you the second benefit. It actually gives you the set of words that are in the list. Right? So now you know all the unique words in the list as well, right? Because your words are the keys of the map. And so that's an often useful thing to do. Yes?
Do you map to like a generic type, like an any, like as in like other languages like Swift have like an any type?
So the answer is, oh wait, so, you mean, can I make a map where the key or the value is anything? Is that what you're saying? Yes, the answer is yes. But, so the way you would do it in Java is your key or your value would be the type big O object. Yeah, so that would work. What is the complexity of this algorithm? So I'm going to loop over the strings in the list, right? So that's, if my list has n elements in it, this loop is going to run n times, right? For a hash map, contains key is O1, right? Get is O1, put is O1, and that puts also O1, right? So these are all expected constant time operations for a hash map, right? And so you end up with a complexity of big O of n, right? Which is much better than O(n) squared that you would get if you just tried to use the list itself. Okay. If you want to, so the keys form a set, right? Because they have to be unique. And so that means you can ask a map for its set of keys, right? So the key set method is the method that returns the set of keys. Now notice there's something funny here, right? So when I ask the map for its set of keys, I get back a set of strings, so that makes sense in this case, right? Because I'm counting the number of times each word appears, right? But the type here, it's not hash set, it's not tree set, it's not linked hash set, it's just plain old set. Okay? So ignore that for now, but this is the way you would write it. I'm going to explain this in a few slides. Right? Once you have the key set, you can do whatever you want with the keys. Right? So now you can go and you can loop over the keys, for example. Right? As you loop over the keys, you can ask the map how many times does this key appear. Right? And then you can do something with the value as well. Right? So I can do something like print that word appears that many times in the list T, for example. Right? Or you can use it for whatever else, whatever computation you need to do. Right? So if you can get the keys, can you also get the values? And the answer is yes, you can get the values if you want. Right? Now the values in a map are not unique, not necessarily unique. Right? And so they form what's called a collection. Right? So when you call the values method, it returns this thing, big C collection. Right, which we also haven't seen yet, but I'll explain what a collection is in a few slides. Right? So you can think of a collection as, the easiest way to think of it is think of a collection as being a list where there's no index. Right? So the only thing you can do with a collection is iterate over the elements. Right? But just like in the previous case, once you have that collection of values, you can iterate over that collection, and then you can do something with each value in the collection. Right, so here I'm counting the number of I'm summing the number of times each word appears. Right, so I'm counting the length of the number of words in the original list. Right, and then you can do something like compute the average occurrence of each word by dividing by the size of the key set. Okay, so key set and values. So key set doesn't specify what kind of set it returns. Right? All it says is that it returns a set of some kind. Right? So you don't know if it's a hash set, a tree set, or some other kind of set. Yes, question?
For the set and collection, do you need to know what type they are?
What type?
Like, because there's for the key.
You need to know what the element type is.
Okay.
Yeah. So you don't know what type of set this is. You just know that it's a set. Right? Similarly for the values method, right? It says it returns a collection, but it doesn't say what kind of collection. So you don't know if it's it's not a set because the values aren't necessarily unique, right? But you also don't know if it's a list or not, right? All you get back is this thing called big C collection, right? And the question is what are these things? Because we haven't seen these before. So set and collection are what are called interfaces in Java. Right? So what's an interface? Right? So in its most common form, a Java interface is a specification, but not an implementation of what's called an API. Right? So an application programming interface. Right? So all that means is that an interface is a bunch of methods. Right? So it's a bunch of methods, but the methods have no implementation. Right? So an interface says what methods exist in the interface. Right? The interface says what the methods promise to do, right? But it doesn't define how those methods are implemented. Right? So for example, the list interface, so list is also an interface, specifies what methods every list must provide. Right? The set interface specifies every method that a set must provide. And I'll explain what a collection is in just a minute. Right? Now, the difference between a set and, between a class and an interface is that a class does provide the implementations of the method. Right? So if a class implements an interface, right, then what that means is that the class must provide every method that's in the interface. Furthermore, it has to provide an implementation of every method that's in that interface. So the ArrayList class actually has an implementation of every method in the list interface. So interfaces are, in fact, types in Java. Right? So classes are types. Interfaces are also types. Right? And so what does that mean? It means that you can make a variable whose type is also an interface. Right? So here I make an ArrayList object, right, using new and its constructor. Right? On the right-hand side, though, I can make a variable whose type is not ArrayList, but it's just plain old list. Right? Similarly here for the hash map, right, I can make a hash map object, but I can store it in a variable whose type is just plain old map. Right? And so what does that let you do? Well, it means later on, if I decide that I don't want to use a hash map, I want to use something else, right, because the problem I'm trying to solve requires a different kind of map, I can come in and just change this hash map to tree map or some other type of map. Right? And I don't have to change the thing on the left-hand side. Right? Okay, so these things that are, these lists, sets, and maps that we've been using, these are all part of what Java calls the Java collection framework. Right? So it's made up of a bunch of interfaces. Right? And so the interfaces define what methods the various types of collections support. Right? Then it's made up of a bunch of classes. Right? So the classes are the types that actually provide implementations of the interfaces. And then there's a bunch of algorithms. So there are some classes that contain nothing but static methods. Right? Those static methods operate on either collections or maps. And this is a picture that shows you how the various types of interfaces are organized in the Java collections framework. So this thing here is called a UML class diagram. So UML is short for Unified Modeling Language. Right? It's a visual language. Right? So in other words, it's a language where you draw stuff. And it's used to describe object-oriented programs. Right? This is just one type of diagram in the language. Right? So a class diagram shows you information about the structure of classes, right, and how they're related to one another. So the way you draw one of these diagrams is your classes or your interfaces, they go inside a box, right? The name of the interface or class goes inside the box. If it's an interface, then there's normally some sort of annotation that says it's an interface, right? This is actually the older style of drawing an interface in UML. There is a newer style as well. So at the top of this hierarchy of interfaces is this thing called collection, right? Now there's this thing called list here, right? And there's an arrow pointing from list up to collection, right? And so what this diagram is trying to tell you is that list is what's called a sub-interface of collection, right? And all that means is that every method that's in collection is also inside of list, right? And list is allowed to add its own methods as well, right? Set is also connected to collection with an arrow. Right? So set is a sub-interface of collection. Right? Every method that's in collection is also in set. Right? A sorted set is a sub-interface of set. So every method that's in set is also inside of sorted set. Right? By extension, that means every method that's in collection is also in sorted set. Right? Notice there's no relationship between sorted set and list or set and list. Right? So if list adds a bunch of methods, set doesn't get those. Right? Neither does sorted set. Okay, so in red, all of those interfaces include all of the methods that are in collection. Right? And in blue, the sorted set interface includes everything that's in set. Right? So sorted set is the interface that tree set implements. Right? So every tree set guarantees all of the methods that are in sorted set. Right? Hash set has all of the implements the set interface. So it only guarantees the methods that are in the set interface. Right? So in other words, if there's a method in sorted set, hash set can't use it. Array list and linked list both implement the list interface. So the maps are separate from the other collections. Right? And if you, and I'll show you why in a moment, why they're separate in a second. Right? So the map forms its own interface, and then there's also a sorted map that's a sub-interface of map. Right? Sorted map is the interface that tree map implements. Right? And map is the interface that hash map implements. Now, why are these different interfaces compared to list and set? Right? And that's because of the way that you use a list and a set versus the way you use a map. Right? So if we go back to the documentation for, say, map, where's contains equals. So when you put something into a map, right, you don't put just one thing into a map, right? You put a key and a value pair into the map, right? What happens when you add something to a list, though? Right? So Java 8 list. Whoops. Hopefully it finds it. Thank you. Right? So when you add something to a list, right, you only put the one thing into the list, right? You put the one element into the list, right? So the way that you use a list or a set, right? Set also has an add method, right? Is fundamentally different than the way you use a map, right? Which is why they have separate interfaces, right? And why they're not all under one single interface. Yeah.
Would you not consider like a map to be like a 2D array?
Yeah, so you might consider a map to be a collection of entries, right? In which case you could try to shoehorn it into here, right? But when you look at the other methods in map, right? Inherently the methods in map, when you access, so when you try to get something from the map, you're getting it by a key, right? Whereas when you try to get something from a list, you're getting it using an index. And you can't get something from a set. So it doesn't make sense to try to fit it in under this interface here. Yeah. Okay, so what is a collection? So go back to this picture here, right? Well, lists and sets, they're both collections, right? That's what this picture is trying to tell you, right? A list is a collection, a set is a collection, right? So what can you do with lists and sets, right? Or what are lists and sets, right? Well, they're both groups of objects, right, where each object is called an element of the collection. Right? So the collection interface, it defines the most general operations that you can ask a collection to perform. Right? So you can ask for the size of a collection. Right? You can ask, is the collection empty? Right? You can ask, does the collection contain an element? Right? You can ask a collection to add an element to itself or remove an element from itself. Right? And so on and so on and so on. Right? So a list is a type of collection. Right? But it holds its elements in a numbered sequence, right? So in other words, you can use an index to get to any element in the list, right? That's something that a collection that you can't do with a collection. So list adds its own methods that let you get or set an element by index. Right? So for example, in the list interface, right? There's a get and a set where you pass in an integer index, right? There's also a remove where you pass in an index. Right? Notice the syntax for declaring the interface, right? So instead of class, you use interface, right? And this, the list interface extends the collection interface, right? So that keyword extends means that list is a sub-interface of collection, right? Everything that collection has, list also has. You don't have to repeat all of the methods that are in collection. Right? So in other words, all of these methods are automatically part of the list method of the list interface as well. Right? Now list can go ahead and add extra methods if it wants to, and it does. Right? Set's funny. So set is a collection where you can't, or that doesn't contain duplicate elements. Right? The set interface doesn't add any extra methods compared to the collection interface, right? So it only contains methods that it gets from collection, and that's it, right? It changes the specifications for the methods, though, right? So a set is a collection where there are no duplicates. So when you look at methods like add for the set interface, right? It says add doesn't allow duplicate elements to appear in the set. Okay, so map is its own collection, is its own interface, right? And it provides methods like puts, right? You can get by key, you can remove by key. Right? And there you can get the key set, you can get the values, you can actually get the set of entries. So if you want to get all the entries, so each row of the map, you can get that as a set. Right? So the entry set is just the set of rows, right? So you get back a set. Now the rows are represented by this type called map.entry, right? Which is the first time we've seen one of these before, right? So all of our types so far, just been one word, right? For the entries, you have to use map.entry. So what this is trying to tell you is that this class called entry, or this interface called entry, is actually defined inside the map interface itself, and you can see it right here. Right? So here we've got an interface called map, and inside that interface is another interface, right? One called entry. So this is called a nested interface. So you can define an interface inside an interface. You can also define a class inside of a class. And later on in the course, so several weeks from now, we'll see examples of why you might want to define a class inside of a class. All right. Any questions so far? So I'm just going to move on to the next deck of slides, which is the object-oriented programming slides. So this is classes. Okay, so I'm just going to quickly review some important concepts before actually showing you how to make your own class. Right, so remember what a type is. So a type is just a set of values and the operations that you can perform with those values. Right? So int is a type. The set of values are the integer values between integer min value and integer max value. What can you do with them? You can do arithmetic and compare them. Right? String is also a type. Right? So what are the set of values that you can have for a string? Well, any sequence of characters would be a string. What can you do with a string? You can do stuff like equals, char at, index of, and so on and so on and so forth. Right? Similarly, list is also a type. Right? What are the set of set of values that represent lists? Well, any sequence of 0 or more elements can be a list. Right? What can you do with a list? Well, you can do things like get, set, sublist. You can test if two lists are equal. Right? You can test if two sets are equal, and you can test if two maps are equal. Right? So two lists are equal if they have the same number of elements in the same order. Two sets are equal if they have the same number of elements and each element appears in the other list, in the other set, sorry. Two maps are equal if the maps have the same number of entries and they have the same entries not necessarily in the same order. Okay, so we know about the primitive types, right? So they're basically the numbers and true false, right? And we also know there are these reference types. Right? So string, list, array list, those are all reference types. Arrays in Java are also reference types. Right? Even arrays of primitive values, they're considered reference types. A class in Java is just an implementation of a reference type. Right? So the string class is just the thing that defines how a string works. Right? Classes are also called user-defined types. An object is just an instance of a class, right? So the number 1 is an instance of an int, right? The string hello would be an instance of the string class, right? And the list with the element 1 in it would be an instance of an array list class, for example. Right? The way you make an object is you take the class. Now remember, the class defines what information is in the object and what methods the object has, right? So to make an object, you can think of taking the class and using it as a blueprint. You just copy the class, and that produces an object. Right? So that's the simplest way to think about it. Right? So here's an example. So if I have the array list, if I want to make an array list object, right, I use the array list class to create an object. Right? And I do that by calling a constructor with the new operator. Okay, so what's a reference then? Right? So a reference is just an identifier that you can use to find an object in memory. Right? So for this group, right, you can think of a reference as just being a pointer, right? Because that's actually what it is in most Java implementations, right? References are just memory addresses. Right? So any type that's not primitive, it's a reference. Right? And so one way to think about this is to use what's called a memory diagram. Right? So in a memory diagram, we have 3 columns. Right? So here I'm going to have a variable name. Here I'm going to have an address. And in the third column, I'm going to have a value. Right? So this is a very, very crude approximation of how memory works on your computer. Right? So your addresses, that's just the row number. Right? So it starts at 0, goes down to whatever. It doesn't matter. Right? They're sequential. The value, I'm allowed to put one thing in each one of these boxes. Right? So typically, this is going to be a single number. So here we've got 3 lines of code. Right? I've got a primitive variable x, and I've assigned it the value 1. Right? So what does a snapshot of memory look like? Well, somewhere in memory, there's a variable called x. Right? So I'm going to store that at address 100. It doesn't matter where you put it. You can put it wherever you want. Right? The value that's associated with x is the actual value minus 1.0. Right? And that's because x has primitive type in Java. Now, the next line of code actually causes a whole bunch of stuff to happen in a language like Java. Right? So we've got new array list. Right? The new operator causes memory to be allocated for an array list object. So somewhere in memory, an array list object appears. So here I've drawn it at address 700. Again, it doesn't matter where you put it. You just can't have overlapping stuff. Right? So somewhere where there's empty memory, I've got an array list object. I don't know what's in that object, so I'm just putting array list here, array list string object here, because we don't actually know what's inside an array list. Right? But somewhere in memory, there's an object. Right? What value do you store with t? Well, T is a pointer to that object. So in other words, it's the memory address of that array list. Right? So I'm going to write that as 700A. Right? If you ever see an A after a number on a memory diagram, it's indicating that it's an address, right? And not the numeric value 700. Right? So T is a reference to the object at address 700. When you write U equals T, right, what that means in Java is, so whenever you write X equals Y in Java, or in this case U equals T, literally what it means is go find the value of T and copy that onto U. Right? So go find the value of T, that's 700, copy that into U, so that's 700. Right? If they were primitive types, so if I had Y equals X, then Y would be minus 1. Right? Take that value, copy it into the variable Y. Right? So what do you have here? You've got two references to the same object. Right? I've only got one array list object. I've got two references to that object. Right? So for you guys, it's two pointers to the same object. Right? If I use T or U to change the list, then I can use the other variable. And that other variable, when you look at the list, will see the changed list. Right? Because they both point to the same list. All right, that's a good place to stop. And we'll pick that up from slide 12 in the next lecture.